Hi, welcome to the Low Ridge On-Site Technologies training video for the Oscar II system in Virginia, which is a pad system for dispersal only. My name is Jake Lau, I'm an employee of Low Ridge, and I'll be taking you through the design video. To start, we'll just go over an overview of what an Oscar II is. It's a proprietary technology that's genesis is in Washington State, and in Virginia, it's for a final disposal or dispersal only. The name Oscar is an acronym for describing what the system is: an on-site sand coil area recharge. Here's a picture of a finished site, and you can see where the coils have been laid underground. All the information that I'll be referencing during this presentation is in our current design manual, which you can find on our website, oscaronsite.com, in our production information page under Virginia State. The title of the design manual that I'll be referencing is Design Manual. In staying to the Oscar II design manual, it's important to note that an engineer is required to implement this system. No deviations are allowed from this manual unless they are approved and via the Virginia Department of Health. Here's an overview of the Oscar II using some of the stock drawings that we have available on our website, oscaronsite.com. So you'll have two tanks. One will either serve as where the pretreatment is, or, depending on the application, the septic tank effluent that's just settling. Here you'll have the pump tank with our headworks that we have spec'd out, and a supply and flush line going out to the drain field, which again is this series of drip tubing in the shape of a coil arrangement on top of a bed of sand. There are two components of an Oscar system. Not surprisingly, the first one we'll mention is the Oscar coils, or those coils of that drip tubing. We have two sizes of these coils, and we have a couple of names for them that go synonymously, and depending on what we're talking about, it's convenient and beneficial to know both. Our first size is an OS50, or a 5-foot coil. The 5-foot is referring to the diameter of the coil, which is important later on when we get into the nitty-gritty of the design. And an OS50, or a 5-foot coil, can handle a 50-gallon per day design flow. An OS100 can handle twice the design flow, which is 100 gallons per day, and we also refer to it as a 7-foot coil because it's 7 feet in diameter. The second component of an Oscar is sand. We have an approval which has spec'd out ASTM C-33 sand, and we have a minimum of 6 inches of depth of sand underneath the coils in all our applications for Oscar II. Here is an image of an OS50. This green background has nothing to do with the system. It's just there to help the picture have some contrast. Also important to note that this PVC tubing or pipe that's keeping the tubing in place has no water running through it. The only reason that it's there is to hold that tubing in its shape, in that coil shape. Here's an image of an OS100 coil, and you can see that it's crossing the same bracket 9 times, where the OS50 was only crossing 5 times. Again, it's taking up a bigger surface area, but has twice as much tubing. Some more differences between the OS100 coils and the OS50 coils are in their square footage of area that they take up. The OS50 coil, having a 5-foot diameter, will have a 5x5 dimension of area that each coil will take, and that'll give you 25 square feet per coil. With the number of emitters that are in each OS50 coil, we have 50 emitters, and that equates to 2 emitters per square foot. Moving on to the OS100 coils, again, it has twice as much design flow capacity, so 100 gallons per day per OS100 coil. Its area is going to come out to twice as much as well, 50 square feet. But in twice as much area and twice as many emitters, you're still going to come out to that same 2 emitters per square foot. So here are just some pictures of the OS50 and OS100 coils in the field. So here's a picture of the OS50 coils before they're backfilled and the OS100s. So they'll look the same in their application. So a reminder, this is a primary dispersal component. This is a dispersal technology for Virginia. And it can be used with other technologies as pre-treatment that will help meet treatment level 2 or treatment level 3. Now, the soil depths or vertical separation that we're looking for, if it's just septic tank effluent that's going out to the coils, we need a minimum of 18 inches of undisturbed soil or vertical separation. Treatment level 2, we need 12 inches below the coils, but only 6 inches of that needs to be soil. So if you're with me, we always need 6 inches of sand underneath the coils. So in the case of we have a pre-treatment unit that meets treatment level 2 that's going out to the Oscar drain field, you'll just need the 6 inches of sand that you automatically need under the coils, and then only 6 inches of vertical separation of undisturbed soil to give you a total of that 12 inches. Again, that's for treatment level 2. For treatment level 3, with disinfection, if that's the level of treatment that you're getting with your pre-treatment unit before going out to the Oscar 2 system, then you only need 6 inches, and that 6 inches can be the spec'd out C-33 sand. The system must be designed by an engineer, as a reminder, but as you can see, this system is very beneficial in sites where you have very shallow soil conditions. I'd now like to walk you through a couple of example sites for design, one for a flat site and one for a sloping site. So we'll start with the flat site. That seems to be simpler. So just to take these arbitrary numbers as we move forward to walk through all the calculations, we're going to have a 300 gallon per day design flow. And we're going to assume that this site has been spec'd out, given the soil, for a 73 minute per inch percolation rate. What we'll do is we're going to take that design flow of 300 gallons per day, and we're going to divide by the loading rate, which is associated with the percolation rate. These numbers, by the way, are all going to be in the design manual for the Oscar 2 system, including the table that has the loading rates that go along and are associated with each percolation rate. So in this case, that loading rate is going to be 0.25 gallons per day per square foot. So to get the basal area, we just take that design flow of 300 gallons per day, divide by that loading rate of 0.25 gallons per day per square foot, and we get a total basal area of 1,200 square feet. Okay. From here, we're going to begin the work of finding the length for our dimensions of our drain field, for our Oscar system. So, given our example site that we're working on of 300 gallons per day, it's also the equivalent of 2 bedrooms in Virginia. So you'll look up in our table that we have, and we have a table for OS 50 coils and a table for OS 100 coils. We'll move on with this example with OS 50 coils, but I also included the number that's given for OS 100s just to illustrate that we have those specific numbers for both our sizes of coils, because it will change the dimensions depending on the size of coil you use. So for OS 50s, for a 2-bedroom system, you can see that our minimum shoulder length is going to be 33.5 feet. So that's what we'll use moving forward. Next, to complete that length, we'll need to take into account the side slopes that we're going to have on the edge of our drain field or our Oscar system. So our side slope ratio that's required is a minimum of a 1-to-1 ratio. Now with 6 inches of sand, that 1-to-1 slope is going to bring that side slope on each side out another 6 inches. So since there's 2 sides to each drain field, we're going to multiply that 6 inches by 2, and that's going to give us an additional foot in side slope. So now we take that minimum length that we found in that table from our design manual of 33.5, we add our side slope of a foot, and that gives us a total of 34.5 feet in total length. Okay. From here, just basic math to calculate our width. Since we already know our total basal area of 1,200 square feet, we take that and divide by our length, which includes that side slope that we just figured out of that 34.5 feet, and that gives us a width of 34.8 feet. What you do just to make life simpler is just round up to the nearest foot, and it'll give you your dimensions of 35 by 35.5 feet. So in this case, it's a square drain field. So now to walk through an example site for design that's a sloping site, it's very similar. The main difference being our calculation of side slopes, because it's essential that the coils be level. And so to keep the coils level, if there's a slope, then on the down gradient side, that side slope is going to have to be bigger because it's going to have to be built up more with sand to keep those coils level. So let's assume that our slope grade is pretty big. Let's say it's 20%. So taking the same system of 300 gallons per day with that 73 minutes per inch percolation rate, which has that loading rate associated with it of 0.25 gallons per day per square foot, we'll do that same calculation to get our 1,200 square feet of overall basal area. So same thing so far. Now we'll go ahead and find the length in the side slopes. And so we'll start out just as before. We're using OS50s, and so we'll look that up in our table in our design manual, and we'll find that same shoulder length of 33.5 feet. And then what we're going to do to find the side slope is we're going to multiply the slope by the inches of the diameter in the coil. So in this case, the OS50 is 5 feet in diameter, which equates to 60 inches. So we'll take that 60 inches and multiply it by 20% or 0.2, and that will give us an answer of 12 inches. This 12-inch answer is an additional sand to what's already required. So we already have 6 inches required. That's what we're going to have on the upslope side of these coils. So we'll add those together to give our total side slope for the downslope side, which will give us 18 inches of side slope. So again, just as before, since we have two sides to the slope in each drain field, we're going to have our 33.5 feet plus that 18 inches of side slope times 2, which is going to give us an additional 3 feet of side slope. So we have 33.5 plus 3, which gives us a total length of 36.5 feet. So from here, it's exactly the same. Now that we have our length, we take our total area of 1,200 square feet, divide by 36.5 feet, and that's going to give us 32.9 feet. Round up to the nearest foot, and our dimensions for our sloping site is 37 by 33 feet. So as you can see here, we have this red line that's a side view of the coil. So you see the coils here. So this is a side view. Up here we have that 6 inches. And on this downslope side, so you can see it sloping on this downslope side, that's the 18 inches that we need underneath the coil to make sure that this coil is level on a 20% slope. You'll also notice that on a sloping site, the coils are going to be all the way up against the top up gradient part of the spec'd out drain field. That's important because we want gravity working for us as the water gravities down, and we want to utilize all of the basal area, so we have the coils at the top part of the up gradient side of the drain field. Another thing to note is the coil arrangement. So continuing with the arbitrary numbers that we've been working with, a design flow of 300 gallons per day, or 2 bedrooms, there are coils per lateral. And there's a table, in this case, since we're working with OS50 coils, table 1 in the design manual. You'll see that for a 2-bedroom system, you'll have a total of 6 coils, which makes sense. Again, if we're talking about that 2-bedroom being a 300 gallon per day system, and an OS50, each one of those OS50 coils can handle 50 gallons of design flow. If you have a total of 300 gallons of day design flow, then you'll need 6 OS50s to be able to meet that requirement of that 300 gallons per day, as laid out in this table. So all of that math is already done for you. So your 2-bedroom system, you need 6 coils. And here's the important part for the coil arrangement. We also have laid out you'll need 3 laterals of 2 coils per lateral. So if you think about a lateral being however many coils you have paired up with only one connection to a supply and flush line. So as you can see here, for the OS50s, let's just call this side, this black line on the side of the coils, your supply line. And let's call this side your flush. Okay. So you'll see that this first coil has a connection to your supply line, and then the other end of the coil is attached to the coil next to it, and the end of that coil is what goes into the flush. So when the pump kicks on, it's going to supply both these coils before it goes to your flush line. And so that makes these two coils one lateral because they're hooked up together before the connection of a supply and flush is complete. And so you have 3 laterals of 2 coils each. Now up here, in this case using OS 100s, for the same design flow, each coil is its own lateral. So each coil will have its own connection to a supply and flush line. So you'll have 3 coils, 1 coil per lateral. Again, all of that's spec'd out in the tables that we have in the design manual. Now, because these systems can be utilized in such shallow soil, if you have excess soil and the homeowner or you'd like to design it so that there isn't any kind of mound, albeit shallow, in the individual's backyard or wherever the drain field is being spec'd out, if you have the excess soil, you can dig down into the ground to make sure that you leave enough remaining soil to meet your requirements, and you can have this potentially ending at grade or flush with the rest of the land around the area. The last thing we're going to calculate is the total dynamic head for our supply line. We use the Hazen-Williams formula to calculate the friction loss, and we just add that to our elevation to get our total dynamic head. For our standard packages, the supply line for our Oscar is always assumed to be a 1-inch in diameter Schedule 40 PVC. The pump that we have in our standard package has an excess head of 50 feet. So when you're calculating the total dynamic head, if it's above that number of 50 feet, the system is then a custom design and must be identified, and therefore you need to immediately call Low Ridge for assistance to see if we need to do anything or what we need to do to accommodate the custom design. Just to give, this is a sample pump curve. And so if we're calculating our head and we come to this point, we have this much excess head, and so we'll be good. As you can see also in our table, the same table that we looked at when we were calculating the laterals for our coil arrangement, we also have that number of 50 feet in excess head. So if you exceed that, then it becomes a custom design. A custom design also happens if we have a design flow over 500 gallons per day. Now, if the design flow is just above 500 gallons or is just above our excess head, then chances are the solutions will be rather simple, whether it's just upsizing the pipe from that inch Schedule 40 PVC to 1.25 inches. But it is important that you reach out to us because it could involve multiple pumps, it could involve a new headworks, or a number of other things. So our septic tank requirements are spelled out in our manual, and I encourage you to look at that. But the quality of the actual tank needs to meet the Virginia Department of Health treatment standards. And generally speaking, a 1,000-gallon tank will work as a good minimum for that first septic tank, or whatever is required for that pre-treatment unit if you're using that prior to the pump tank that's going out to the Oscar II system. For the discharge tank, again, look at the manual, but typically for the average residential site, a 1,000-gallon minimum tank will do the trick. Here's an overview. First tank spills over to the second tank, our spec'd out headworks, going out to your drain field. Inside, you have a pump and 2 floats. Here's a closer look. Pump and 2 floats. And the total area, again, just walking through everything. Here's your tankage. So here's where your pre-treatment unit would be. If you're using septic tank effluent, then this is just a settling tank. Our pump tank, pump, 2 floats, going out to our headworks, and then out to the coils. So cover material. The only thing that's required is an additional 6 inches of sand on top of where the coils lay. cover soil can be used, but it's imperative that the soil that's used is very low in organics. I'm going to jump a couple of bullet points, and you'll see down here, do not use topsoil mix. So if a homeowner wants to plant things on top of the drain field, more power to them, but if they go down to Home Depot and just get the best gardening topsoil mix, that's very high in organics, and that capillary rise of the water will stay there, it'll get stuck there, and you'll have a perpetually mushy drain field. So not topsoil mix. We're talking about sod. We're fine with straw. Just throw some grass seed. We're fine with some vinca minor or a jute mat. But truth be told, just throwing some grass seed over the top of the sand, and that drain field will grow grass faster than anything else on site with that nutrient-rich water. And just a good thing to know, our Oscar II package that we send out from our headquarters at Low Ridge is a basic package that's going to include the control panel, the headworks necessary, the pump, and the miscellaneous parts to have all those things fit together. So for you, now that you've watched this video, the next steps for you is to make sure that when you're watching this video, it's in a relative time frame close to when you're actually going to do a design. So if you watch this and you don't design an Oscar system for another year, before you design it, watch this video again. Once you watch it and are ready to do your next design, give Low Ridge a call. So you can either call Dave Lau, the owner of the company, at 425-750-4922, or myself at 425-633-0913. And we'll go ahead, ask you a couple follow-up questions, give you an opportunity to ask any questions for us, and we'll go ahead and put you on our list of certified professionals, which will be posted on our website, and you're more than welcome to have a copy of that as well. And you'll be ready to move forward and engineer your first Oscar system.